All right, let's start chapter 2 today. So in section 2.1, we're going to talk about what are known as conditional statements. Chapter 2 is going to be kind of a break from a lot of the normal type of math things. We're going to talk more about some logic. We're going to talk more about proofs and like step-by-step processes to solve problems. So the first thing we talk about what are known as conditional statements. So a conditional statement here is simply any if-then statement. So if you want to go out with your friends, then you need to finish your chores. So anything that's saying if this happens, then this will happen. Now in an if-then statement, there are two parts to each statement. The hypothesis is the part that directly follows the word if. So when I say if you want to go out with your friends, your hypothesis is you want to go out with your friends. The second part of the statement is called the conclusion, and that conclusion is the part that follows the word then. So then you must finish your chores. Your conclusion is you must finish your chores. As far as if-then statements go, identifying those two pieces is going to be pretty important. Another thing on here that you see is the symbols. So sometimes they'll use symbols to denote a conditional statement. So P is usually the defined value for hypothesis. Q is generally associated with conclusion. And then the arrow here is simply read as if P, then Q. So that arrow just tells you it's an if-then statement. If P happens, then Q happens. So if we look at some examples here, on this first example here, it says if you can predict the future, then you can control the future. So one of the things you're going to be expected to do is take a conditional statement and identify the hypothesis, which we're going to underline, and the conclusion, which we're going to typically circle. And generally the instructions will tell you that. So we're going to underline the hypothesis, circle the conclusion. So in the first statement, the hypothesis is anything following if, so we do not include the word if. We simply underline everything after it until we hit then. The conclusion is everything after the word then, so we're not going to circle the word then. We're going to circle everything afterwards so you can control the future. So underline hypothesis, circle conclusion. For our second example, we look at the statement. It says vertical angles share a vertex. Now, we have a problem. In order to do hypothesis and conclusion, we need an if and we need a then. So when you're given statements in this form, you need to convert them to if-then. So when we do this, there may be times where we have to add a few words to make things make sense. So if I was going to change this into an if-then, I would say if they are vertical angles, then they share a vertex. Okay, so if they are vertical angles, then they share a vertex. So you can add little auxiliary words to make the statement make sense when you add the if and the then. Now when I go to identify my pieces, again, I don't want to include if, so I just underline they are vertical angles. I don't want to include it then, so I circle they share a vertex. So when you have these conditional statements, if they're not if-then already, you need to make them if-then, and then you need to underline and circle the appropriate pieces. The next thing we talk about here is what's known as the truth value. So when we want to know if a statement is true or false. So to show that a conditional statement is true, we have to show that every time the hypothesis is true, the conclusion is also true. So that needs to be something where it's just obvious that every time the hypothesis happens, the conclusion will definitely happen. If we want to show that a conditional is false, so if we want to show that we have a false statement here, we need to find what we call counterexample, for which the hypothesis is true and the conclusion is false. So we want to find one thing that would make the first part of the statement true, but the second part would be completely false. And so we'll look at some examples here to kind of talk about what this means. So when you see a problem say determine if the statements are true or false, or they might say determine the truth value, they're asking, is this statement true or false? So our hypothesis here, two angles form a linear pair. Our conclusion, they are supplementary. So what we have to decide is that always true? If I know two angles are linear pair, are they always supplementary? Or can I think of a time where that wouldn't be the case? Now, we just talked about this in the last chapter. If we have a linear pair, linear pairs always add to 180. And in the last chapter, we always talked about the fact that supplementary angles always add to 180. So, if I have a linear pair, they have to add to 180. If they're supplementary, they have to add to 180. So this statement will always be true. If I know I have a linear pair, then I know I have supplementary angles. There's no possible way I can have a linear pair that's not supplementary. Now, if we look at the second example here, it says if a number is divisible by 5, then it is odd. So my hypothesis, a number is divisible by 5, my conclusion is it must be odd. So we have to decide, is that always true or is it sometimes true? So can I find a different or a counterexample to show that it's false? So if I think about numbers that are divisible by 5, they could be like 5, 10, 15, 20, 25, 30. Now our conclusion says every number divisible by 5 must be odd. But if we think about that list we just had, this is a false statement because we have a counterexample of 10 or 20 or 30 or 40. All of those are divisible by 5, but they're not odd numbers. So if you're going to say that a statement is false, you have to provide one single counterexample. There might be more, but you just have to pick one that's going to tell you for sure that the first part is true, the second part is false. When we negate statements, so this is the next piece here, when we negate a statement, we're going to say the exact opposite of the statement. And typically the way we're going to do that is we're going to put the word not into a statement, or we're going to take the word not out of the statement. So an example, the statement is the sky is blue. If I want to negate that, I'm going to say the sky is not blue. So it's just a matter of putting the word not into the statement. Or if I had a statement, if the sky is not gray. So the sky is not gray. If I want to negate that, I would say the sky is gray. So you're either going to put the word not in, or you're going to take the word not out to negate a statement. All right, so this next part I'm going to kind of introduce in pieces here. So a conditional statement, we already talked about, is a if-then with a hypothesis and a conclusion. So with a conditional statement, we might have an example like the one here, where it says if the measure of angle A is 15, then angle A is acute. So we have an if-then. If the measure of angle A is 15, then angle A is acute. Now there are three related statements to this conditional that we can be using at any given time. The first of which is called the converse. Now the converse is when we take the conditional and we switch the hypothesis and conclusion. So we take what was the if and we make it the then. We take what was the then and make it the if. So as you see in the example here, now angle A is acute became our hypothesis. The measure of angle A is 15 became our conclusion. So we took the conditional and we just flip-flopped it. Now if and then stayed put. If is always first, then is always second, but the statements afterwards flip-flop. So with the converse, switch hypothesis and conclusion. The inverse takes the original, so converse comes back to conditional. So we take the conditional and we flip-flop it. Inverse also comes all the way back to the conditional, and what it's going to do is it's going to negate. It's going to add the word not or take the word not out of both parts of the statement, and that's important that you make sure it goes to both parts. So our original statement was if the measure of angle A is equal to 15, then angle A is acute. Down here in the inverse, they say if the measure of angle A is not equal to, and that's a new symbol for some of you, An equal sign with a slash through it means not equal to. So if the measure of angle A is not equal to 15, then angle A is not acute. So we just took the original statement and put the word not into both parts of the statement. The contrapositive is the last type of statement. Now, the contrapositive can do one of two things. So the contrapositive can flip the inverse. So it can either flip the inverse. So we're going to take the inverse and flip-flop it. If angle A is not acute, then the measure of angle A is not equal to 15. So that's one possibility. The other possibility is we negate the converse. So I could negate the converse. The converse was if angle A is acute, then the measure of angle A is equal to 15. So if I put nots into that, if angle A is not acute, then the measure of angle A is not equal to 15, I get my contrapositive. So basically, there's a couple different ways to do that contrapositive. Whichever one makes more sense to you, use that method. For some people, they even go all the way back to the conditional and say, okay, well, I'm going to flip it and put the nots in all at once. So it's like doing both the converse and inverse all at one time. So whatever makes more sense to you, you have three different methods to create that contrapositive. So just be aware that we're just moving hypothesis to conclusion, or we're adding knots, or we're doing both. So for an example here, write the conditional, converse, inverse, and contrapositive. So first thing, if we want our conditional statement, we need to first write it as an if-then statement. So this if-then, so all birds have feathers, we could convert that to an if-then by saying if it is a bird, then it has feathers. So there's my conditional statement. When I want to do the converse, I'm going to flip-flop my original statement. So I still start with if, but now I'm going to say if it has feathers, then it is a bird. So I'm just flip-flopping the two pieces of the statement. So if it has feathers, then it is a bird. When I want the inverse, I go back to the conditional. So I go back to the original, and I need to put nots in. So if it is not a bird, then it does not have feathers. Okay, so if it is not a bird, then it does not have feathers. So converse, flip-flops, inverse, put the word not in. Our last statement then is the contrapositive. In the contrapositive, again, we can flip the inverse, negate the converse, or do both things to the conditional. So either way, we should end up with a statement that says, if it does not have feathers, then it is not a bird. So we're simply taking the inverse, is the way I typically do it. Take the inverse and just flip-flop. So if it does not have feathers, then it is not a bird. So this is going to be something you're going to be expected to do on the homework and on the quiz or a test, is write the conditional statement, so convert it to if-then, and then flip-flop for the converse, negate for the inverse, and then do both for the contrapositive. So you're going to be asked to do both of those things. The last thing we need to talk about is what's called a condition or a biconditional statement. So biconditional statement has a very unique phrase in there, which is if and only if. If and only if replaces the whole if-then portion of the statement. So when I had a statement that was like, if you want to go out with your friends, then you have to finish your chores. So that's an if then. It reads one single way. So I read one way here. Now if I can reverse that statement, so if I flip-flop, so looking at the converse, if the converse reading the same or opposite direction is also true, then that means my statement actually can go either direction. So that's what these notations up here are saying. So if you want to go out with your friends, then you must finish your chores. If I flip-flop that, if you finish your chores, then you can go out with your friends. So as we flip-flop, both statements would be true, which means we could write it as a biconditional. You can go out with your friends if and only if you finish your chores. Okay, so that's kind of what we're looking at. So an example here, we'll just look at this second example right here. So we talked about one that worked. So with the if and only if, so when we rewrite it, there's no if, there's no then. It's just hypothesis, if and only if, conclusion. Now in this example down here, the first thing I would need to do is write my conditional statement. So if it is a rectangle, then it has 4 sides. Now, if it's a rectangle, then it has 4 sides. That is a true statement. So the conditional must be true. Also then, I need to check the converse. Now the converse would flip-flop this statement. So I would say if it has 4 sides, then it is a rectangle. Now, here's the thing. If I look at it in reverse order, if it has 4 sides, then it must be a rectangle. So I have to think, is that always true, or could I have a different 4-sided shape? And so in this case, this statement would be false because my counterexample would be a trapezoid, or it could be a parallelogram, or it could be a square, it could be anything that's not a rectangle. So false, counterexample, trapezoid, or false, counterexample, just a regular quadrilateral. Doesn't have to be a rectangle. So when you're doing this, both statements have to be true in order to convert to if and only if. If only one or the other is true, then there's nothing we can do. This is not a biconditional statement. So with that, you should be able to work through most, if not all, of your 2.1 worksheet. As you're working on the worksheet, make sure you are asking questions. So you can email, you can ask questions in class, but just make sure you look at those. Make sure you check the answer key when it comes out, and make sure everything looks good, and have that ready to turn in a couple of days.